All right, hello everyone. Drew Robb, AI advisor at ERP Suites. I've been with ERP Suites for 5 years now. Worked in products, then in data analytics, data consultant. Now the wonderful world of AI. I've given a number of sessions, a number of presentations this week on getting started with AI, but happy to teach you guys today about some anomaly detection capabilities that we are doing at ERP Suites. Some example use cases as well. And just the high level, what is anomaly detection, what is machine learning, and kind of the outline around all of that. So go through a quick agenda here. So we'll first start with what is machine learning, what is the basis of machine learning. Then we'll go into kind of the types of machine learning, supervised, unsupervised, reinforcement are the three, and then anomaly versus conformity, and what's the important around those, what's important thing about those, and why you need to do both. Really train on both. And then we'll go into some real world use cases. And then we'll end that with a demo that we worked at ERP Suites with, building out around sales analysis and warehouse analysis using Oracle machine learning and really Oracle OCI capabilities. And then we'll end with a Q&A there. So with that, we'll jump into what is machine learning, right? And you've probably seen it before, and you've probably heard about machine learning. It's really just a branch of artificial intelligence that enables computers to learn data and improve from their performance over time. So really learning on historical data. We like to call it a feedback loop, right? So every time a user input goes in, every time new data gets added, it learns from that and becomes more intelligent. The key components of those really dropping down there is training data. Really important. Training data is obviously important. I spoke a lot about that this week. Having good data quality, data being kind of the gold, as Oracle likes to call it too, of your business. Having good data management leads to very good machine learning models and really good machine learning solutions to actually glean good, insightful data off of that. You also need to obviously need a model to run it through, and the model is going to really depend on what sort of predictions come out of it and what sort of decisions come out of that model that you run it through. And there's many different models that you can use. It just really depends on the type of machine learning you're looking to do, right? And that runs into the algorithm. What algorithm are you using? Are you trying to do a classification model or a cluster model, right? I know the one in our demo today, we're using support vector machine learning as well. So it just really depends what idea you're trying to solve when you're going into the machine learning side of things. And then inference, right? The ability for a learned model to get new and unseen data. And as we talked about with training data, it's the ability to gain that knowledge into the model whenever you're training it. That's also a very important key concept when building out these machine learning capabilities and machine learning models. With that, I'll jump into three of them, and we have examples on two of these. But supervised learning, that's really learning around labeled data. So if you think of that, you think of your structured data inside of JD Edwards or your SQL database or your Oracle database. That's really all the supervised learning. You're actually learning and you're trying to define a single target outcome that you're getting from that. And we'll have a financial example on that coming up here that will explain more and give you a better perspective of what a supervised learning model will really look like. Next is the unsupervised learning. So this model really looks at detecting patterns in unlabeled data. So what we like to do this, there's a few examples with this one. And that's with, for example, what we use is Vision is one of our tools that we like to use to actually gain insights from images, right? So very unstructured data. You can also think of that as getting data from documents. So document understanding is another session we had during this week. So you think of those as like unsupervised learning. And the one we're going to talk about later as well is actually in the manufacturing space and using machine learning with detecting anomalies in manufacturing, right? Using sensors. So really looking forward to sharing that one with you. But that's really unsupervised learning. It's not detailed table-oriented data like supervised learning. It's more unstructured, but you can still glean good insights from those. The third one's reinforcement learning, and this one's very cool. So it really learns from trial and error, and it actually is what we've incorporated into our manufacturing digital assistant and look to incorporate in a lot more of our solutions, where when you actually get data back, if you ask you query on data, do a SQL query, or you want to run through a process and make sure the process is correct. If you're trying to do an automation, um, as our manufacturing assistant does, um, it will come back and actually respond to you and say, do you like this answer? And basically just with a thumbs up or a thumbs down, and you can really train it on if the answer is good or bad based on that. If you joined the keynote today for the As Data solution, you also saw that as well, kind of that reinforcement learning, making sure, once you got the data back, you can actually train it yourself. And it's really that human in the loop aspect that we tried to reiterate a lot during this week in that process. So the humans involved in training the actual model and sending back more data to the model for historical input from the users. So reinforcement learning is a different one. You've seen some real-time examples this week, and we're just going to show you some high-level examples on those top two. So the supervised and unsupervised types of machine learning. With that, we want to jump down to anomaly and conformity. So obviously anomaly is something we're focused on highlight today. It's something unexpected, unusual, and really deviating from often a signaling a potential issue or error. So just really high level examples we're showing there is sales order with a negative quantity. Obviously you'll see that, you'll highlight that in your data, right? You can do it manually, but obviously we want to be more predictive today and highlight those examples and potentially get rid of them or notify people, right? So that's the big thing we're getting to with this machine learning data analysis we're going to get into later today. But that's something easy to spot, right? Or even a spike in sales from a dormant customer account is another example we can bring up. And then even getting outside of sales, right? The user logging in from an unusual time or unusual place, even a location. That's just another example of an anomaly that might show up when you're running through your data. Now, taking it to the other side here, conformity really refers to behavior or data outputs or inputs that follow expected patterns. And so really that's like a sales order that includes all required fields and follows your typical format when you're looking at your data, or a user from a company's standard operating procedures, or even data entries that match historical averages. So everything seems to match up. And the reason we bring up conformity is the sole reason that when we're training these models, we don't want to just use data that's anomalous. We don't want to use data that's just incorrect or out of norm or an outlier. We want to use this conformity data in order to train the models and this will help eliminate the bias in the models, right? So the bias that can show up if you have skewed data, or you target a data source or a subset of data that might be favoring one side or the other. So it's really important to understand that all data is important when we train these models, especially conformed or expected results, because that will make you determine and understand what are the actual anomalous transactions or anomalous data sources or anomalous outputs in your data. So just keep in mind conformity. It's very important to train on all your data, as well as the data that's also good and not anomalous. So with that, I'm going to hand it over to Manuel to take you through a financial use case on the supervised learning side of things, where you actually understand the data and it's in a tabular format.
Thank you, Drew, and great, baseline on anomalous and conformity, because those are both equally, as you described, equally important to have a highly useful and accurate model. Here, specifically, when we look at the supervised model, we're talking about accounts payable, wanting to automatically detect erroneous invoices, like overpayments, fraud, or accounting errors. And as you can imagine, right, those two components that Drew talked about, conformity and anomalous, are necessary to be able to, one, on the conformity side, to establish a baseline of what is to be expected, whether it's an average or some other mechanism that establishes a baseline for the model to say, yes, this is fine, right, from a payment perspective. On the other side of the house, you also need anomalous, right? You need kind of those outliers to be able to describe, so that the model can understand what doesn't fit, why it needs to be questioned, raised, and people need to be notified. So in this particular case, real world example, right, is a pretty simple one, but it's something that will resonate, right, in terms of being able to track kind of, payments in the AP side. It is supervised. It falls in the supervised category because, again, as Drew spoke, it is using structured data within JD Edwards, and it is getting trained on that, as well as it'll continue to get trained over time because there may be other types of scenarios that arise, and those got to be taken into consideration. So the model will evolve, is what I'm hoping to say. Next slide, please. Well, with regards to the manufacturing use case, so now let's look at the other side of the house, the unsupervised set of use cases where you might have unstructured data or unlabeled data as well. And this one's an interesting one because back when I was at JD Edwards Oracle still, we came out or probably around the 2017 timeframe, IoT support for Internet of Things, right? With Orchestrator Studio at the time, what it was called for, right, is for Internet of Things. And the idea was to detect symptoms in equipment that would, fall out of range and be indicators of the machine, being near to failure or near to needing maintenance. Since then, right, excuse me, back then we were talking about Raspberry Pi devices to be able to enable that interaction collection of data and have that collection of data being fed back into the JD Edwards preventive maintenance system. Now we fast forward, right, and here we are with machine learning type of capabilities that not only can start, looking and kind of mining that data to figure out, okay, what's really an anomalous type of situation. Maybe it's fallen out of the range, but maybe, it gives a weighted average of 99% of the time it does not fail at that threshold, right? It takes another, step or two in terms of vibration units to really then be something that's indicator. And at one in time, maybe that's when the maintenance person should be contacted to maintain the machine before it breaks down. So, this is an augmentation type of component. If you're already using orchestrations and are doing IoT, this will enhance it. So that's one use case. The other potential use case is around devices. So I spoke a moment about Raspberry Pis being the devices that were doing the basic collection of the data and then feeding it into JD Edwards via orchestrations, right? The Orchestration Studio. But now we fast forward today, and there's devices now that are equipped, they're ruggedized, right, for this kind of purpose. Monitron from AWS being one example that we've worked with. We've worked with customers, and actually we use it in our own operations for our data centers. And we use it to detect and monitor some of those symptoms that I talked about, right? The temperature, vibration, and other metrics. And what it also does, it has incorporated AI capabilities, machine learning. So it will start tracking, it'll start learning. So it's a smart device. So that's interesting. And in this particular example, right, with manufacturing, we're talking about the equipment. Many times we're talking about unstructured data, no labels, and being able to train it, right, on both ends is still important, like Drew said, right, both from the conformity side and the anomalous side. So
yeah, and I was just going to add real quick on that, just the really, and you can kind of see it there, the actionable insights you get from that training, that model, right? And it's going to be based on that historical data, but you also just going to have to train it again. That unstructured data becomes structured data in the end, right? And you're going to start to see what's normal, and then you can, and that's the human in the loop kind of aspect as well. You're going to start to see what's normal and start to train it as well. And then from that, you're going to then start to realize what are the outliers once you get some more data in there. So a lot of data upload and understanding of the data first before you start actually making decisions on the data. And then it can do predictive maintenance, right? Alerting teams to inspect on a service, or if a machine's going to break down is the big actionable insight you get from that. So it's really preventive maintenance, as Manuel was saying. So just wanted to add a few color things as well there. Yep. So with that, we're going to move on to the anomaly flow here. So with this, we're going to talk about the demo we're going to show today. So with this, I just wanted to give a high level flow of what it looks like. So on the left there, you'll just see the box. That's just JD Edwards. So that's your JD Edwards data. Our demo today is going to be on sales analysis and on a warehouse analysis. Specifically with the warehouse analysis, it's around moving certain items to certain warehouses for cost optimization, which is really sweet kind of stuff we're getting into here as far as anomaly detection and machine learning. So we grab the data directly from JD Edwards. We load it into ADW, which has Oracle machine learning. So that's really where the magic happens, is inside of Oracle machine learning, where we actually do the training of the models, right? We do the data prep, the training of the models inside of there, and actually build out the insights. And then using a large language model is actually where we build out the data visualizations that you'll see today in this demo. And we actually embed those into dashboard analytics inside of E1. So you can see them right on your screen. You know, future capabilities is being able to embed these analytics with a digital assistant next to an E1 and being able to, you know, ask the digital assistant and the dashboards pop up automatically and glean insights there. So it's just one of the things we're trying to migrate and combine all these AI services together to create a full-fledged solution. But you're going to see some pretty great things today and how that kind of works. Now, as far as ADW, we said we push the data into ADW because the OML services inside of there. But it's really just going to depend on your use case for traditional databases or the volume of data you have or the databases, the transactional databases you have inside of JDE for how we do that connection to the OML to make all the magic happen and make all these predictive analytics and anomaly detections occur. Now with that, we're going to move over to the demo portion, and I'm going to share a video. Unfortunately, one of our colleagues, Mario Riccardi, could not be here today. He is on the AI and products team here at ERP Suites, and he just provides some fantastic insights, some even higher level architecture, you know, how he gets the data from JD Edwards and Oracle machine learning, and then insights on what he's gotten from those visualizations. And what I want you guys to really think about today when you see this video is really are the possible. Where can you see this working in your business? Like, we're going to show sales analytics and warehouse analytics as well, but where can you see it working in there? Because just with any type of data, with any type of transactions, anomaly, machine learning, you know, you can provide proactive and predictive insights to enhance your JD Edwards experience is what I'm getting at. So without further ado, I'm going to unshare real quick. Manuel, if you want to add any talking points there while I get the video up and running.
Sure thing. I would just add a little bit about, you know, the comments about ADW. Drew is completely spot on. It really depends, excuse me, on your use cases. And if you specifically are interested in being able to connect your JD Edwards data or
Go ahead.
connecting OML, right, Oracle's machine learning directly to your transactional database, your JD Edwards database, that is a possibility. We just need to kind of introspect on a particular set of requirements you have and what have you. But Oracle also supports that. We just need to get into the specifics. So
yep.
Reach out to us if you'd like to have those conversations. Either Drew and I should be able to help you. Go ahead.
Yeah, and as you're watching the video, please feel free to input any questions in the chat. We're happy to answer them as the video is going on, or we can answer them at the end as well. But just feel free to plug questions in as needed. And yeah, so just enjoy the video. And I'm really excited for you guys to see what Mario has put together, as well as the rest of our AI and products team.
Transforming JDE data into actionable insights, anomaly detection, ERP Suites, and Oracle. My goal today is to provide a comprehensive overview of ERP Suite's AI-powered anomaly detection solution, to demonstrate our process and to showcase some real-world examples. My name is Mario Riccardi, and I am on the ERP Suite's AI and products team. And in this video, I'll be highlighting our sales and distribution anomaly detection solutions. And in this, we're using Oracle's autonomous database and machine learning to perform statistical analysis of our JDE data. And this is really to highlight that today's competitive landscape, businesses are running powerful ERP systems like JDE, and they generate an immense amount of data. And this data holds the key to understanding performance and identifying inefficiencies and uncovering opportunities for our businesses. But with so much data, it's really almost impossible to get a sense of patterns just by observation. How do you find in this sea of information what's truly important and truly matters? How do you identify subtle anomalies? How do you identify the transactions or events that fall outside of normal business operations? Transactions that could signal fraud or process errors or identify necessary critical business changes. Manually sifting through this data is time-consuming and generally impractical or even impossible. So this is where our AI-powered solution comes in. We're leveraging the power and intelligence of Oracle Cloud, and specifically the Oracle Autonomous Database and its integrated machine learning capabilities. And using these tools, we're able to automatically find these critical anomalies so that you can make meaningful business decisions. So today I want to focus on practical and high impact applications of turning your data into information that you can use. So our first step is to extract the relevant data from the Enterprise One system. And in the examples that I'm going to cover today, we're taking sales order data and also inventory location data and feeding it into our machine learning processes to discover what kind of patterns exist and also to find maybe some recommendations in the system for changes that will have meaningful value to us. So we're going to extract specific data that we want to analyze, and we're going to load it up into our Oracle database. Now, Oracle has provided us with a database that's well suited for analytical workloads and machine learning. And this includes a range of powerful algorithms and statistical techniques designed for identifying patterns and deviations within large data sets. Here's a picture of the DBMS data mining algorithms and the different statistical models that we can use to find patterns in our data, as well as anomalies. So this in-database processing, it's highly efficient and it keeps your data secure. And it eliminates the need to move large data sets elsewhere for analysis. Once loaded, we train these machine learning models on your historical JDE data and establish a baseline of normal behavior across various business dimensions. In this case, we're analyzing sales trends, inventory movements, purchasing patterns, and more. I should also point out that these models can be run numerous times a day. And as new data arrives, the models score it, identify data points that deviate significantly from the original learned behaviors, and then they're flagged as potential anomalies. Now, let's look at some real-world examples. Here, I have loaded up in my JDE instance the results of our analysis, which in this case is presented as a React website that we've created that holds a number of different charts as well as key insights. We can optionally run our statistical results through a large language model such as Cohere and have it do insights as descriptions. In this case, you can see we have key profit margin insights, extreme negative margins for these particular month and year pairs, suspicious perfect margins, as well as clustering. Under my Sales Anomaly tab, I have 4 different sub-tabs. I can see that the margins that I generally enjoy in my business are somewhere between 0 to 40%. I have a few that are 95 to 100%. I can see sorted by month in this case, my profit margins over time. This data from our lab is probably not the best reflection of real world data. Hopefully it's not. But you can see that in 2021, we had a particularly bad month. But over time, we're generally getting more profitable. We have a number of different charts that we can generate. We're not locked into these based on a customer's need and what's most meaningful to you. Here's another tab in which we're charting our salespeople's results. Here we can see that we have one salesman who's got a very negative profit margin. These two they have negative quantities. Here I'm able to see who has the most number of sales. And again, our key findings that are specific to the data that we've analyzed. And some recommendations that the system has decided that we might want to look closer at. Regions and any anomalies. In this case, our data only has 2 regions. These are based on category codes. Just wanted to point that out. And recommendations. When we look at our warehouse analysis, in this case, I wanted to have data that could inform me on the efficiency of my warehouses in terms of their proximity to my customers, and have the system tell me if there are some optimizations that could be made. So here I see that our shipments to Manhasset, New York, for these specific items, I'm pulling from 2 or 3 different warehouses. This item, there's a warehouse that's 145 miles away, but in some instances we're going 1,600 miles in order to fulfill orders to Manhasset, New York. Here's an opportunity for us to look closer at our warehouses and maybe optimize our inventories. These different locations: Billings, Montana, Chicago, Illinois. So you can see that we have lots of opportunity. Again, different types of charts, cluster charts. Here I can see that my distance per mile, or cost per mile, and my distance are clustered in these different groupings. I can see what my average cost per mile tends to be based on where my warehouse is. Looking even closer at this specific set of data, which the centroid cluster looks at the center of the cost cluster data, I can try to see where, again, I have unoptimized inventory and what my costs are, like we did a moment ago. Now, if I am running this fairly often during the day, I can even pick out individual orders that I may be able to save a fair amount of money with by sourcing that order from another warehouse. So in this case, order 2878, if I have the inventory at a closer warehouse, I have an opportunity to save $20,000 before it's staged and sent out. And then this last tab, reallocation. Now we're looking at a summary that's telling us that we have the opportunity to save $100,000 by optimizing where our inventory is coming from. We can see these items here. I mean, I have really $70,000 worth of inventory, or $70,000 worth of transportation costs that I could be saving a year just by optimizing where these two items are. These visualizations immediately draw your attention to potential problems that are in your warehouse and your operations. They enable your team to investigate root causes, prevent losses, and improve inventory accuracy and efficiency. And the power of our solution isn't just in finding anomalies, it's in translating these findings into real actionable business intelligence. We process the results from the machine learning models and present them in a clear, business-friendly format. For each identified anomaly, we provide insights into what might be happening and offer potential recommendations for action or further investigation. And this empowers your business decision makers with the information they need to respond quickly and effectively. And of course, this means less time spent hunting for problems and more time spent making informed decisions that protect your business and improve performance. So by implementing our AI-powered anomaly detection, you gain a truly powerful tool to automatically monitor your critical business processes and identify hidden issues and transform your data into a strategic asset. So I want to invite you to speak with our experts about how we can tailor our anomaly detection to your specific JDE environment and your business priorities. Don't let critical issues hide in your data any longer. Thank you.
There we go.
Awesome. Any questions from anyone after seeing that? Or the possible pretty great dashboards integrated inside of JD Edwards?
So pretty cool, right? From a data warehouse perspective, that's probably a use case that many of you have. If, however, you have other use cases, right? You're not, using warehouse, or you don't have a warehouse, but you have other scenarios. We touched upon manufacturing, we touched upon financials. This kind of anomaly detection, conformity, machine learning type of solution can be stuff that we're looking at or we're creating in different areas of JD Edwards, because those insights, right, getting deeper insights to your business, as Mario discussed, is incredibly valuable. So the possibilities, please don't look at this session just being a warehouse. We have other solutions, and happy to have conversations with you about any other areas where this kind of functionality would be helpful to get a deeper pulse on your business.